Good morning. In this session, we are going to see about a topic on convection from the subject heat and mass transfer. Natural convection. If the fluid motion is produced due to change in intensity resulting from the temperature gradient, the mode of heat transfer is said to be a free or natural convection. Again, another convection is there, forced convection. If the fluid motion is artificially created by means of external force like a blower or fan, that type of heat transfer is known as forced convection. The motion that results by a continual replacement of heated air by a cooler air is called natural convection current, and the heat transfer as a result of this is called as natural convection heat transfer. Natural convection over surface depends on geometric and orientation of surface, thermophysical properties of fluid, variation of temperature on the surface. The fluid beyond the boundary layer is stationary. The temperature of the fluid is equal to the plate temperature at the surface and gradually decrease the fluid temperature. In case of cold surface, the slope of the velocity and temperature producers remain, but their direction is reversed. Grashof law. It is a ratio of buoyancy force to the viscous force acting on a fluid. Grashof law is equal to buoyancy force by viscous force. The formula is G into beta delta Tx power 3 divided by small v square, where beta is a coefficient of volume expansion. Natural convection correlations. In natural correlation conventions, there is a Nusselt number. The Nusselt number's formula is constant efficiency into resilience number into constant exponent, where resilience number R is equal to Grashof number into Prandtl number. The convection correlation characteristic length. In vertical plane, the characteristic length is mentioned as L. At the inclined plane also it is called as L. But in horizontal plane, the depends upon the hard surface and the higher surface and the lower surface, it may vary. And the vertical cylinder, it is mentioned as L, and the horizontal cylinder, the characteristic length is mentioned as D. The sphere, the pi d. It is a problem on convection. Consider a 0.6 meter and 0.6 meter thin square plate in a room at 30 degrees Celsius. One side of the plate is maintained at a temperature of 90 degrees Celsius, while the other side is insulated. Determine the rate of heat transfer from the plate by convection. If the plate is vertical, horizontal with hard surface facing up, and horizontal with hard surface facing down. For a vertical plate, first of all we have to find out the properties of film temperature Tf, and we have to find out the coefficient of beta is equal to pi by Tf, is equal to 1 by Tf is equal to 1 by 60 plus 273, that we are converting into a Kelvin of 60. The length is 0.6 meter, and the Grashof number, that is Rayleigh's number, is equal to Grashof number into Prandtl number. The value is 7.656 divided by 8. The film temperature is found out by the water temperature plus surface temperature by 2, and the Nusselt number formula, by a Nusselt number formula we have found out a value of 1, the value is 113.4, and the heat transfer coefficient H is equal to 5.306 watts per meter square Kelvin. The heat transfer formula is equal to H into A into delta T. The value is 115 watts. For a plate horizontal with horizontal hard surface facing up, the characteristic length is equal to A by P is equal to L square by 4L. The properties of film temperature is already we know, the value is 60 degrees Celsius. Resonance number is depends upon the Grashof number and Prandtl number. The value is 1.196 into 10 to the power 7. Nusselt number value is 31.76, depends upon the formula heat transfer coefficient, and the heat transfer is equal to H into A into delta T minus delta T del infinity. As per the same formula, we are using the plate horizontal with the hard surface facing down. And the heat transfer radiation by radiation Q is equal to epsilon into A into lambda into T in by T out. Next problem. The large vertical plate 4 meter high is maintained at 60 degrees Celsius and exposed atmospheric air is 10 degrees Celsius. Calculate the heat transfer. First of all, we have found out the properties of filling temperature is Tf is equal to Tw plus T infinity divided by 2. That is 60 plus 10 divided by 2 is equal to 35 degrees Celsius. For converting into a Kelvin, we will be getting answer 303. And the beta is equal to 1 by Tf film temperature. The beta is equal to 3.25 into 10 to the power minus 3 Kelvin inverse. That is the Grashof number is equal to 3.3743 into 10 to the power 11. That is greater than 10 to the power 9. So it is a flow is turbulent flow. The Nusselt number for a turbulent flow is equal to 0.10 into Grashof number into Prandtl number power 0.33. The value is 720.7. The heat transfer coefficient for value will be 4.837 watts per meter square Kelvin. Heat transfer rate Q is equal to H into A into delta T. The value will be 9675.4 watts. Next problem. A 20 mm diameter horizontal heater is maintained at a temperature of 38 degrees Celsius and submerged. It is submerged in water at 77 degrees Celsius. The surface temperature of the plate is 38 and is submerged in water. And calculate the free convection heat loss per unit length of the heater. First of all the problem, we will be finding a filling temperature. So Tf is equal to Tw plus T infinity divided by 2. And the Prandtl number and Grashof number is equal to 2.18 into 10 to the power 6. That is less than 10 power 9. So it is a flow is a laminar flow. For laminar flow, Nusselt number formula is Z into Grashof number into Prandtl number power n. That is equal to C into resonance number power n. And the value is 21.98 and the heat transfer coefficient H is equal to 692.37 watts per meter square Kelvin. Next, the heat transfer Q is equal to H into A into delta T. That is 470 watts is the answer for the free convection heat loss per unit length of the heater. Next problem, same as a fine wire having a diameter of 0.02 meter is maintained at a constant temperature of 54 degrees Celsius by an electric current. The wire is exposed at air is 100 kilopascal and 0 degrees Celsius. Calculate the electric power necessary to maintain a wire temperature if the length is 0.5. This problem we have given a diameter, length and the temperature of the exposed air and constant temperature is given. From that we can find out a film temperature. Tf is equal to Tw plus T infinity divided by 2. Next we can find the coefficient of expansion and the Grashof number into Prandtl number value will be 4.05 into 10 to the power minus 5. From that we are finding a Nusselt number C into Grashof number power n. The value will be 0.375 and the heat transfer coefficient H is equal to 492.6 watts per meter square Kelvin. And the heat transfer Q is equal to H into A into delta T. The value will be 0.836 watts. Next problem, the estimate the heat transfer from a 40 watts bulb at 125 degrees Celsius kept in air at 25 degrees Celsius. Next, approximate the tube to be a 50 mm diameter sphere What percentage of power is lost by the free convection? Same as all the problem, we will be finding a film temperature TW minus T infinity by 2 depends upon the temperature of the bulb temperature and air temperature. That is 125 plus 25 divided by 2 is equal to 75 degrees Celsius. Next, the Grashof number and Prandtl number is less than 5, greater than that 10 to the power 5, and the Nusselt number is equal to 2 plus the formula is 2 plus 0.5 into Grashof number and Prandtl number power 0.25. The value will be 15.6. The H value will be 9.38 watts per meter square Kelvin. Q is equal to H into A into delta T is equal to 7.71 watts. The percentage loss of free convection is equal to 40. Depends upon in the question we have given a heat transfer from 40 watts. So 7 on 7 divided by 40 is equal to 19.27 degrees Celsius.